600 feet beneath the Atlantic, off the western tip of Cuba, something sits on the ocean floor that challenges our standard geological models. In 1999, a commercial survey looking for shipwrecks found a series of massive, geometric shapes resting in the silt. The survey was led by Paulina Zelitsky, an ocean engineer with decades of experience in Soviet military sonar. When she reviewed the pulses reflecting off the seafloor, she didn't see random debris. She saw a grid of symmetrical structures arranged in a layout she described as an urban arrangement. The scientific establishment responded with the null hypothesis. This is the assumption that the structures are simply unusual geological formations. Nature can produce striking geometry on its own, like these hexagonal basalt columns, which can trick even experienced analysts when viewed through low-resolution sonar. This natural explanation provided a convenient reason to let the site sit ignored. For 25 years, the mystery remained uninvestigated, tucked away behind the safety of institutional skepticism. Part of the silence was due to geopolitics. Because the site sits in Cuban territorial waters, the United States trade embargo blocked well-funded American research institutions from collaborating on a serious investigation. Beyond the political barriers, there was the risk to scientific reputations. Pursuing a site that contradicts the established timeline of human history is a difficult sell for researchers dependent on traditional funding and peer approval. That neglect ended in 2024. A team returned with a suite of modern technology: multi-beam bathymetric sonar, 4K camera-equipped ROVs, and autonomous drones. Their goal was to apply a stress test to the natural theory and finally close the case. But the high-resolution data did not provide the boring answer. Instead of proving the structures were natural, the new technology revealed details that the existing models cannot easily explain. The 2024 survey revealed that the site is nearly double the size of original estimates, covering 31 square kilometers. The largest feature is a pyramid-shaped structure rising 52 meters from the base, roughly the height of a 15-story building. This scale is impressive, but the material composition of these blocks is what truly challenges the natural hypothesis. Using sampling arms, the ROV collected physical material from the site. Laboratory analysis confirmed the structures are composed primarily of granite, a continental rock that forms under specific conditions associated with landmasses. Finding continental granite at these depths is a significant anomaly. This material does not form naturally on the volcanic basalt substrate that makes up the seafloor in this region. While tectonic activity can fracture rock into linear shapes, it does not typically create coordinated geometric relationships between separate structures, separated by hundreds of meters. The 2024 team used AI-assisted pattern analysis to map the site's geometry. The algorithm found the principal axes of the largest structures align across the complex with a deviation under 2 degrees. It then analyzed the spacing between these features, identifying a repeating proportional ratio of approximately 1.618, the golden ratio. This is the same mathematical relationship found in the architecture of the Parthenon and the layout of Stonehenge. The probability of this ratio appearing by chance at this site was calculated at less than 1 in 8,000. These specific mathematical relationships are a hallmark of engineering, not the random fracturing of a tectonic plate. If these are engineered structures, the next logical step is to see if they belong to a known culture, like the Maya or the Olmec. To find the construction date, researchers extracted sediment cores from the base of the formations. By radiocarbon dating the organic material in the deepest layers, they could determine when the site was last disturbed. The results date the most recent major event at the site to between 10,000 and 12,000 years ago, the exact period when sea levels rose at the end of the last ice age. That exact chronology creates a significant historical gap. The site appears to predate the first stone cities of the Maya or any other recognized regional civilization by thousands of years. The data from the rescan has left the standard explanation strained. The geometry is too precise to be a tectonic accident, and the dating is too old for any culture currently in our records. These results point toward a possibility that academia has long avoided. It suggests that a culture with advanced architectural capability occupied this region during the Ice Age, only to be erased when the environment changed. The 12,000-year dating connects the site directly to the end of the last glacial period. As the ice sheets rapidly melted, global sea levels rose fast enough to submerge coastal landmasses within human lifetimes. For those living on the coast, the ocean would have been an unstoppable invader. Generation after generation, their homes and monuments would have been swallowed by the rising tide, eventually becoming the silent ruins sitting 600 feet below the surface today. At the peak of the last ice age, sea levels were 120 meters lower than they are today. Huge stretches of the continental shelf that are now shallow ocean were once dry land, capable of supporting human populations. This includes the Persian Gulf, parts of the North Sea, and vast land bridges in Southeast Asia, regions that would have been the most resource-rich areas for ancient humans to settle. This suggests a staggering blind spot in archaeology. We have been building our history using the inland sites that happen to survive, while the most developed coastal settlements likely sit at the bottom of the sea. Internal excavation is the next required step to confirm the nature of these structures. But the data gathered so far suggests that a significant portion of the human story may be sitting quietly beneath the waves, waiting for us to look.